Hello friends, in this video we are going to talk about impact loading. Now before going to impact loading, let's understand the basic difference between gradually applied load and suddenly applied load. Now suppose there is a block. Suppose this is the block which is kept on a ground. This is a block kept on a ground and I have to apply a load of P onto this block. Now the process or the way by which I'm going to apply the load P onto this block will decide whether it is gradually applied or suddenly applied. If I go on applying the load gradually, that means initially the load on this block is 0 and I I increase the load by 1 Newton, then again the load is increased up to 2 Newton, then 3 Newton, and so on. If I go like this up to load P, that means I am applying the load gradually. Here we can see the same with the load versus time diagram. I am increasing the load gradually. Starting from 0, I have to reach P. I am increasing the load gradually. So this is what gradually applied load means. Now whatever the formulas that we have derived earlier is for gradually applied load. That means the deformation, the delta elongation which we have derived is PL by AE is for gradually applied load. Let's say this as static, delta static. So delta static is nothing but PL by AE, and the stress here sigma static is nothing but load upon cross section area. So this gradually applied load is simple. We know the formulas for it, that is PL by A and stress is P by A. Now in the case of suddenly applied load, again the same example, a block is kept on the ground and I have to apply a load P onto this block. Now initially the load was 0 and now I have increased the load from 0 directly to P in a very short interval of time. Such type of loading is called as suddenly applied load. Here we can see the same in this graph. Here initially the load was 0 and within a short interval of time the load has increased and has reached to P, and so this is called as suddenly applied load. Now here the deformation will not be the same as it was in gradually applied load. So what's the difference here? Let's say delta suddenly applied SA. The delta of suddenly applied, the deformation will be 2 times of what we have seen in delta static, and the stress in suddenly applied will also be 2 times of sigma static. So this is actually what we should remember. That means whenever the load is suddenly applied, we have to multiply by a factor of 2 to get the actual elongation and the actual stress that gets developed into the block because of this suddenly applied load. Now I think you must have understood what's the difference between gradually applied load and suddenly applied load. Now we will move on to impact loading. What impact loading actually is. Now here impact loading, the load is in the form of weight. Here P, load is in the form of weight P and it is at a certain height of H. Now this vertical bar is our element or block here on which we are going to apply this load. Now when we release this load from height H, it comes down and strikes to this collar. This is nothing but collar. Now because of this impact of this load onto this collar, there will be a load applied on this, element. Let's say it as Pi. So load applied on this is Pi. The actual load was P, which has fallen from height H, and the load acting on the element because of the impact. Let's say it as pi. Why I means instantaneous. Now what's the relation between this instantaneous load and the actual applied load? Now the so we have to find instantaneous load. Now instantaneous load we can find out by multiplying some factor into our load P. We have to multiply it with something to get our instantaneous load. Now as this load has some potential energy and this load falls onto this collar, and then the load applied on my vertical bar will be pi, correct? That means pi will be obviously greater than p. That means this something has to be greater than 1. Let's call this something as impact factor. Now we have to multiply by impact factor to get our instantaneous load. Now there is a formula for this impact factor. Here I am not going to derive the impact factor. I am directly going to give you the formula. So of impact factor, let's say I impact factor is given by 1 plus square root of 1 plus 2h upon delta static. Now here h is nothing but height from which the load is falling down, and delta static means the deformation of the element if this load P would have been acting gradually. Now if this load P would have been acting on this element gradually, then we know that the elongation of that bar would have been delta static is equals to PL by AE. So this delta static we have to use it here to find out the impact factor. So I think you must have understood the concept of impact factor. Now impact factor is really important because it helps us not only to find the instantaneous load Pi is equals to impact factor into load P, it also helps us to find out instantaneous elongation. Delta instantaneous is equals to impact factor into delta static. Again, instantaneous stress is also found out by multiplying with impact factor sigma static. So if we conclude this impact loading concept, what we have to do here is we have to follow just three steps for solving impact loading problems. First thing is find out delta static in the given problem. Find out delta static. Then second, find out impact factor. Because delta static is necessary to find out impact factor, we have already seen the formula. The formula says impact factor is nothing but 1 plus square root of 1 plus 2h upon delta static. So we need delta static to find impact factor. So first of all, find delta static, and then second step is find impact factor, and third thing is find whatever is required. If you want to find out instantaneous elongation, you can find out like this. Just multiply static elongation by impact factor. If you want to find out instantaneous stress, multiply it by impact factor, and here you go. Just follow these three steps and you will be able to solve any problem on impact loading. Now let's try and solve some problems. Now here, a weight of 10 kilonewton falls by 30 mm. Now here they have given that load, value of load is P is equals to 10 kilonewton, falls by 30 mm. That means it falls from a height of h is equals to 30 mm on a collar rigidly attached to a vertical bar, and that vertical bar of 4 meter long. So length of that vertical bar is 4 meter and 1000 square mm in section. That means cross sectional area of that vertical bar is 1000 mm square. Find the instantaneous expansion of the bar. So again, what is the first step? First step is delta static. Step 1 is delta static. We know what is, how we can find out PL by AE. So here P is 10 kilonewton, so I'm writing 10 raised to 4. Length is 4 meter, that means 10 raised to 3 divided by area, that is given as 10 raised to 3, and value of E, that is 210 into 10 raised to 3, converting it into megapascal. Now what we get here, 10 raised to 3, 10 raised to 3 gone, 10 raised to 4 gone. That means 4 by 21 mm. Now use this delta static to find the second step, that is impact factor. Impact factor. So impact factor is 1 plus square root of 1 plus 2h upon delta static. So delta static is h value. So delta static, so put here value of delta static as 4 by 21 and value of h, what it is given, 30 mm. So if here put 30, so the answer that we will get here will be 18.77 mm. Now once we get this impact factor, we can find whatever we want. What they have asked is instantaneous expansion of the bar. Now this is the static expansion of the bar. Now to find out the instantaneous expansion, that is delta I, what we'll do is impact factor times delta static expansion of during static. So it comes as 18.77 into static means 4 by 21. The answer that we'll get is 3.57 mm. So this is the instantaneous expansion of the bar. This is how we solve problems on impact loading. Now there are few problems in which it is not that easy to get this delta static. There are some other ways, like we will go and see another problem in which the method of finding delta static is a bit different. So we will look into this. Now this problem says a block of 5 Newton is dropped over a spring whose stiffness is 90 Newton per meter. So he has given that block is P is nothing but 5 Newton, whose stiffness is K, stiffness is 90 Newton per meter, and the block is dropped from a height of 200 mm, h is equals to 200 mm. Then find out the instantaneous shortening of the spring. He has asked us to find instantaneous shortening of the spring. Now this is the same problem of impact loading, as this block is there and it is falling on a spring. It is falling on a spring. This height they have given. Now they have asked us to find the instantaneous shortening of the spring. Now when we use this formula, the step 1, in case of element, delta static is equals to PL by AE. This is nothing but deformation or elongation, and this is load. If we compare this with spring, P is equals to K into X. This is the load, this is the stiffness of spring, and this is the deformation. So if we compare, if we convert this formula like this, P is equals to AE by L into delta static. So if we compare this to formula, we can see that this formula first and this formula second, if we compare this to formula, we see that this is the same formula. Now AE by L is nothing but stiffness of that element, and here X is nothing but the static elongation. So here in this case, if I want to find the static elongation, what I'll do, here load is given as 5 Newton and stiffness is already given as 90 Newton per meter, correct? That means here my delta static will come in meter, correct? So what is the value of delta static? Delta static is nothing but 5 by 90 meter. If I convert it into mm, what I'll get is 55.55 mm. Now here first step is done. We are done with the first step. Delta static is equals to 55.55 mm. Now the second step is to find out the impact factor. So impact factor, we already know the formula. What it is, 1 plus square root of 1 plus twice h by delta static. Delta, delta static, we know it is 55.55 and h value is given as 200 mm. So if we substitute these two values into this, what we get? We get a impact factor as 3.86 mm. Now what they have asked us to find, now in this case they have asked us to find out the instantaneous shortening of the spring. It is nothing but the dimension by which this spring will get shortened. That means it has asked us to find out instantaneous elongation, instantaneous deformation. So delta instantaneous is nothing but impact factor into delta static. So impact factor is 3.86 mm and delta static is nothing but 55.55. So answer that we are going to get here is 214.62 mm. So just to follow this three basic steps in impact loading problem, and there are different ways of finding delta static. Try solving numerous problems and it will help you to gain dominance on this concept. And if you like the content, please do subscribe the channel and press the bell icon. And in the next chapter we'll going to discuss about principal stresses, complex stresses and principal stresses. So thank you very much.